Okay, after that, we will go to example 10. We have 3 kilograms of water inside a container. It has a pressure of 100 kilopascal as well as a temperature of 150 degrees C. And we need to find out the volume. Okay, again, spend some time to do this, and I will reveal the solution to you. Okay, let's see the solution. Here, we get a pair of values, pressure and temperature. So the pressure is 100 kilopascal, and the temperature is 150 degrees C. This is very important. I need to emphasize this. If you see pressure and temperature given to you simultaneously, then the pure substance must be in either the compressed state or the superheated state. The reason is that because if it is in a saturated state, then once you know the pressure, because it's the saturation pressure, then you can immediately know the saturation temperature, because we know that they have a dependence with each other. Similar for the saturation temperature. If you know the saturation temperature, then of course you know the saturation pressure. We do not need to give it to you. So if you see these two values given to you as a pair, then it will be either compressed or in a superheated state. But whether it's in a compressed or superheated state, we need to go to the saturation table to see. Okay, so first of all, we either go to table A4 or A5. It's up to you whether you go to table A5. For example, in this case, I go to table A4. Suppose I go to table A4. Then what happened? Table A4 is the temperature table. Okay. We make this one the given temperature, so we search for the properties at the 150 degrees C. So here, for 150, here, the pressure would be 476.16. Okay. But what's the given pressure? The given pressure is 100 kilopascal, which is smaller than the value I have told you, 476.16. What does it mean? If it is at this pressure, then it will be in a saturated state. But if the pressure is less than this, then we have less pressure, and it will become a superheated vapor. Okay, it will be vaporized. So we say that 150 degrees C corresponding to 476.16 kilopascal. This one is greater than 100 kilopascal. Okay. How about if I use table A5? Well, it's similar. If you use this given pressure to check table A5, then you will see 100 kilopascal would correspond to the saturation pressure of 99.61. 99.61 degrees C. And it's smaller than the given temperature. Of course, it's superheated because the water is heated to a much higher temperature. So we can see that if you use these two tables, either one, you can get the same conclusion that it is in a superheated vapor state. Okay? Well, in the later problems, if we need to determine whether it's a superheater or not, then I will just go to one table only. Either table A4 or A5 is okay. You just choose one and then check for this pair of value, whether one of them is greater than the given one, or this temperature is smaller than the given one. Then you can get the conclusion. Okay, it's up to you. And we need to find out the volume of this container. Well, here we have given the mass. So what remains is to find out the specific volume. So here, the volume is equal to mass multiplied the specific volume, so equal to 3 multiply. Let us go to the superheated table, that is table A6. So 100 kilopascal, that means 0.1 megapascal. The temperature is at 150, so we have, this one is for 150, okay, 1.9367. So 1.9367, it will be equal to 5.810 m cubed, or 5.81 m cubed. So this is our answer. This example illustrated that if you have a pressure-temperature pair of a value, either it is a compressed liquid or is a superheated vapor. So in order to determine whether it's compressed or superheated, you need to go to the saturated table to find out whether, for example, you have a given pressure. If this one is a saturation pressure, then what's the saturation temperature? Or if you have the saturation temperature, what's the pressure? And based on your understanding on the general behavior on the superheated vapor, then you can get a conclusion that, well, it is actually a kind of a superheated vapor, okay, based on my argument. And the argument has stated in the video. Okay, so that's example 10.